I hope all of you can read the sum AB greater than 0 given. Why? Because otherwise this will not be defined. And fx is this, 3 parts it has. It is continuous at x equal to 0, then the value of b by a. Will you approach the way you have started for your board exam? Drawing graph is not so easy for this sum. You won't be able to do it. So don't go for that. You go by formal definition first, then see the requirement of the problem. For continuity at x equal to 0, limit x tending to 0, that left hand limit on fx will be equal to the functional value at x equal to 0 will be equal to the right hand limit. This is the concept. Now you will be putting the value for different parts here. First one, limit x tending to 0 minus is this part, tan a plus 1x, b tan x by x. f0 they have given equal to limit ax plus b square x square minus root ax by, and this is x into root x. I am writing the same format. Now the problem is reduced to evaluation of these limits. Do I need to use the L'Hopital rule for that? If required, then do it, otherwise don't. These all limits can be reduced to standard one. The last one, as I see, rationalization will help you once you have cancelled some factors. This is x tending to 0, tan a plus 1x we are going to evaluate, plus b will come outside, tan x by x equal to limit x tending to 0. See, root x is a common term in inner and rear. So, I will be taking root x common from numerator, and this is x into root x. Okay? Since x not equal to 0, you have every right to cancel it. So, this one will be limit. See, here x tending to 0 means a plus 1x is also tending to 0. I am doing all the steps in details. Maybe question arising in your board paper. Is it? Past years JEE question they ask in board paper. If they ask, then you know the method. Even it will help you to answer your board paper. And you will write always the logic as x tending to 0. This implies a plus 1 into x tending to 0. And here, this is the standard limit, because tan x by x, limit x tending to 0 also 1 equal to, for this part I would like to rationalize. Why? Because just little bit mental calculation, if you multiply this a plus b square x, sorry, a plus b square x minus root a by its conjugate solved, then it will be changed to what? By removing the root, it will be in terms of x only. So that change we wanted to cancel it from inner and rear. So this implies, now this is a standard limit, this part is going to be a standard limit, isn't it? And a plus 1 will be outside, this part is 1 plus b equal to 3, and this one I forgot to multiply the denominator. You must multiply both. So this will be limit, after rationalization, this square a plus b square x minus a by a plus b square x. Okay, hope you have understood. Now simplify it. A plus b, and this is plus 1 equal to 3 equal to limit, and see this x also getting cancelled, this one with this one. So b square by b root a plus root a. These two are getting cancelled. Now nothing is undefined on the right hand side. So this will give you two equations, one, and here that 3 must be equal to 1 by root a. X equal to 0, if you put, only root a is left over there. So 3 equal to 1 by root a to root a. Okay, and this b is lost in the previous step, so bring it back. So b by 2a equal to 3. This implies that b by a equal to 6. Hope you have understood. So option D going to be the correct one. B by a is equal to 6. This is also I have chosen from 2024 paper. If this function continues at x equal to 0, what is the value of a square? So this also going to be a standard limit, as I guess. The standard limit will be for limit x tends to 0, a to the power x minus 1 by x equal to log a base e. Before we solve it, let us analyze the given function. Numerator, there is 70 to the power x minus 9 to the power x minus 8 to the power x plus 1. So why did I guess that limit going to be like this? Because probably we can factorize it. This minus the numerator. I have written just the numerator. 9 to the power x common. So this is going to be, isn't it? So it is given that continuous at x equal to 0. For continuity at x equal to 0, limit x tending to 0, numerator is already factorized. This by and this must be equal to a into log 2 log 3. You know, this is the condition for continuity of a function. As the function is not given separately for less than 0, greater than 0, we can use at both the places. That's why. Now, we'll start solving by L'Hopital rule? No. That's why I told you in the beginning, the concept of limit is very important. This kind of limit, the denominator term, you have solved earlier. So I rationalize the root. That helps a lot always. If you multiply by this, will be changed to 2 minus 1 plus cos 6. Root a minus root b, root a plus root b. That is a minus b only. A into log 2 log 3. This implies that into 9 to the power x minus 1. This one is alone now. Once you multiply it by this, it helps a lot, but here we don't need it. Because I guess that we'll be getting 2 or 3 standard limits over there. This is a log 2 base c, log 3 base c. Let us simplify it. This 1 minus cos x going to be 2 sin square x by 2. To change it into standard one, we need to divide by x square or x square by 4. So divide by x square first. Give 1x to this and the other one to this. And here 2 sin square x by 2 by x square. We have divided numerator and denominator by x square. So this will be, if you put the limits here, it doesn't matter. Root 2 plus 1 plus 1 is again root 2. A log 2 base c, log 3 base c. So this implies limit x tending to 0, 8 to the power x minus 1 by x. None of them are undefined. So you can split into product of limits or quotient if required. This also not undefined one. So you write sin x by 2 by x by 2 whole square. It's coming 4, but there was 2. So you need to multiply it by half. And this is root 2 plus root 2 equal to a log 2 base c, log 3 base c. This is what? A to the power x minus 1 by x log. This is what? Base is e. If you want to write, you write log 9 base e, and this thing will be multiplied with 2 root 2. Now do you find something here? Yes. What is that? This log 8 log 2 cube, 3 log 2, and this is 2 log 3. So you write 3 log 2 into 4 root 2 equal to a log 2 base c. See, these two are getting cancelled. So a is what? A is 24 root 2. So a square, I think this was the requirement of the sum. Then a square is equal to what? A you got here 24 root 2, a square will be square of this into 2. This is 1152. I hope this is your option. Yeah, 1152. Option C is the correct answer for this sum. Okay. Look at this sum. This is also from 2024 paper. This function is continuous everywhere in R. M is the number of points or F is not differentiable. Then M plus A plus B plus C equal to what? This session I have chosen those sums which you can start with confidence. I guess those were good in calculating limits. Concept of continuity also you have. You can solve it smartly. Why? Because for continuity you just write the condition first. What is that? For continuity at x equal to 0, you will get one condition. At x equal to 1, another condition. Okay? And f is not differentiable at which point? That also you have to see. For continuity at x equal to 0, what condition will be there? Limit x tending to 0, the left hand limit, a minus b cos 2x by x square. Here functional value and right hand limit will have the same value. So 0 square c into 0 plus 2. I have taken the value over there because we are answering MCQ. So limit x tending to 0, a minus b cos 2x by x square equal to 2. To get some quick insights about this sum, let me analyze with the help of the cos 2x expansion or with the help of L'Hopital rule. See, here the form is 0 by 0. Is it? Check once. If it is 0 by 0, what's the condition is required? Then only you can use L'Hopital rule. To get the form 0 by 0, under what condition? That we need to analyze first. That form is 0 by 0, then only you can use L'Hopital rule. If for x equal to 0, that a minus b cos 2 into 0 must be equal to 0. I mean denominator must be 0, numerator must be 0, denominator is 0, that we can observe. If form is 0 by 0, then only L'Hopital rule can be used. And this gives us the relation which we need for this sum. Just put b equal to a here. Limit x tending to 0 cos 2x by x square equal to 2. You take a outside. 1 minus cos 2x is 2 sin square x by x square. Isn't it? This one is the standard limit. 2a. Doing it for you, that's why I am writing in details. When you do it for yourselves, then you can do faster than the way I do it here. A equal to 1. So b also must be equal to 1. Okay? A1, B1. F is continuous everywhere. So with the value of A1 and B1, can we decide about the right part? For continuity on at x equal to 1, what do you get? Limit x tending to 1, cx plus 2 must be equal to limit x tending to 1 to x plus 1. So this implies 1 square 2 into 1 plus 1 C is coming to be 0. Okay. Now see the function for this part it changed. For C equal to 0, it is just x square plus x plus 2. And this one 2x plus 1. Here derivative at x equal to 1 is what? ddx of this function at x equal to 1, 2x plus 1, this is equal to 3. Okay. But here derivative ddx of 2x plus 1 is what? This is equal to 2. So it is not differentiable at 1. Isn't it? The function is not differentiable at 1. At x equal to 1. So number of points it is not differentiable. We can judge by considering this part also. A minus b cos 2x. So in a and b you got. This is changed to 1 minus cos 2x by x square, that is 2 sin square x by x square. At x equal to 0, will it be differentiable? See, the right hand limit is going to be at x equal to 0, right hand limit is going to be what? 2. But left hand limit, left hand derivative, when you calculate, this is going to be undefined, because x square derivative will help you to understand, ddx of sin square x by x square, if you calculate ddx of sin square x by x square, if you calculate, see, x to the power 4 x square 2 sin x cos x minus sin square x into 2x. This is not defined at x equal to 0. Even you cancel the factor x. So the function is not differentiable at x equal to 0 also, because here you are getting the value at x equal to 1, the derivative 2 plus c, that is 2 only. ddx c is how much? Sorry, c we got 0. So this part was 0 actually. So this is 0 value will be equal to 2, not 3. But here if you calculate at x equal to 0, the value of derivative, it is going to be undefined. So it is not differentiable at x equal to 0 also. Clear? So the value of m is what? 2, not differentiable at 0, not differentiable at 1 here. Clear? Hope you have understood. So the option D is going to be correct. Alright? Because A plus B plus C, no, A and B is there, value is there. A equal to B equal to 1 and M you got 2. A equal to B equal to 1 you got. So, and C equal to 0 you got. So M plus A plus B plus C, 2 plus 1 plus 1 plus 0. This is going to be 4. So option B is correct. That is 4 only. Understood? Another one from 2024, 4th April morning shift. This JEE main question, only one concept lies over there, otherwise it's not difficult at all, very easy to do. Just under root 1 minus cos x will be what? Three parts given as it is. Alpha beta belongs to R. Function is from R to R. But you need to check whether this limit exists or not. Yes, it of course exists, because when you are calculating under root 1 minus cos x, it is going to be 2 sin square x by 2. Root 2 multiplied by mod sin x by 2. Now for x greater than 0, sin x by 2, this will be plus sin x by 2. Okay? Now if you just use the condition for continuity at x equal to 0, for continuity at x equal to 0, limit x tending to 0, that left hand limit part, this divided by x square will be equal to f0. f0 is alpha. Limit x tending to 0, beta root 2, and this one we have confirmed, that will be root 2 sin x. Now simplify this one. 2 sin square x by x square is alpha. Beta root 2 sin x by 2 by x by 2. If you do it, you need to adjust this term over there, that you multiply here by 2. So that I am taking outside. And when x tending to 0, x by 2 tending to 0. So 2 is outside. Sin x by x whole square alpha beta by root 2 into 1. So what do you get? This is also 1. 2 equal to alpha beta by root 2. So alpha is 2, beta is 2 root 2. Your problem is to find the value of alpha square plus beta square, that is 2 square plus, so this is 4 plus 8, value is 12. Small mistake is there in my typing. This will be 1/3. This limit calculation looks a bit difficult here. You agree or not? Because 1 plus ax to the power 1 by x. How to tackle with this thing? Let me tell you, a to the power b, you know e to the power b log a. Frequently you are using this thing in class 12, class 11 also you might have used. So for evaluation of this limit, we will go for this transformation of exponential into log. So this function continuous at x equal to 0, then e to the power a into bc. Don't be confused with this huge term. Okay? So what you will do there, you write for continuity at x equal to 0, limit x tending to 0, 1 plus ax to the power 1 by x equal to the functional value equal to limit x tending to 0 to the power 1 by 2 minus 2, and this thing x plus c to the power 1/3 minus 2, the right hand limit. Okay. So here you just change it, limit x tending to 0 e to the power 1 by x log 1 plus x 1 plus b, and this is limit x tending to 0. See, if it is a limit and it has finite value, a, b, c, all of them have finite value, then it is quite obvious that this limit is solvable. It means we can evaluate. But evaluation, the normal method is rationalize the numerator, rationalize the denominator, and then proceed. But then it will be very big. Instead, I will be using the concept which you have learned in L'Hopital rule. That evaluation of limit, this limit is possible. Evaluation is possible if the form is zero by zero. For this limit, for this reason, when you put x equal to 0, for x equal to 0 you can see numerator going to be 4 to the power half minus 2, 0. Denominator is not c to the power 1/3 minus 2. But it has to be 0 to evaluate the limit. So for evaluation of limit, this must be 0, c to the power 1/3 equal to 2, therefore c is equal to 8. So this one changed to limit. This time I prefer doing it by L'Hopital rule. If you go by standard limit, I have nothing to say, you can do it. Here also form 0 by 0. Put x equal to 0, log 1. So you just take the limit in the index. You just write e to the power 1 by x log 1 plus x equal to 1 plus b equal to limit x tending to 0, x plus 4 to the power half minus 2, x plus 8 to the power 1/3 minus 2. This implies e to the power form 0 by 0. You can differentiate numerator and denominator, isn't it? So it will be 1 by x by 1 by x into a. Wait a minute. This is 1 by 1 plus x into a, denominator derivative is 1. Why have I done this? Because the form is 0 by 0. Okay, we can differentiate. Condition of limit will remain the same, that is x tending to 0, this is 1 plus b, and this is what? This form is 0 by 0 now. So you can differentiate numerator and denominator here, that is 1/3 x plus 8 1/3 minus 1 is minus 2/3. Alright. So this will be e to the power a by 1 plus 0, 1 plus b, and this thing is x tending to 0, 3 by 2 x plus 8 to the power 2/3 x plus 4 to the power 1/2. So e to the power a 1 plus b 3/2, just put the value here, x equal to 0, 8 to the power 2/3 by 4 to the power half. This implies e to the power a 1 plus b 8 2 cube to the power 2/3, that is 4 divided by 2. So e to the power a, if you compare, e to the power a is 3 and b is what? 2. The value of c you already got. The question was to find the value of e to the power a into b into c. E to the power a you got, that is 3. So this is going to be 3 multiplied by 2 multiplied by 8. This is 48. 48 is your option here, isn't it? So the value of e to the power ABC, option B, is going to be correct. One similar problem where L'Hopital rule may be used, I have chosen that came in 2024 5th April morning shift. But you can use the expansion of, that infinite series for sin x, cos 3x, sin 3x also for this sum. So either L'Hopital rule or this one, because here standard limit part is not going to help. This function continuous at x equal to 0, then the value of f0 you have to find. Not given separately for less than 0, greater than 0. So what to do? We go by the condition of continuity. For continuity, we write limit x tending to 0 fx equal to f0. So f0 only their requirement. This implies f0 equal to fx is sin 3x alpha sin x beta cos 3x by x cube. Okay. So this form, is it going to be 0 by 0? Just as per our discussion in the previous sum, I told you evaluation of this limit is possible if the form is 0 by 0. So right hand side, is it 0 by 0 form? No, because this is 0, 0, this one 0, but this one not. So to make it 0 by 0 form, for evaluation of this limit, that sin 0 alpha sin 0 minus beta cos 0 is 1 should be 0. So in the beginning we make it sure that beta going to be 0. Then nothing is left over there. f0 is limit x tending to 0 sin 3x plus alpha sin x by x cube. Form 0 by 0 here. You can use L'Hopital rule. It is 3 cos 3x alpha cos x by 3x square. Not done yet, because here it is 3 plus alpha and this is 0. Okay. So what I'll do there, I'll be differentiating again. The form may be 0 by 0 if C cos 0 plus alpha cos 0, that must be equal to 0. So here the form is 0 by 0 if 3 cos 0 plus alpha cos 0 equal to 0. This implies 3 plus alpha 0. So alpha is minus 3. Substitute there 3 into cos 3x minus cos x by this. So this form is 0 by 0. Again you can differentiate 3 sin 3x plus sin x by 2x. Let us complete the whole sum by using the L'Hopital rule concept only. Again the form is 0 by 0. You can differentiate once more. 3 into 3 cos 3x plus cos x by 2. So answer is 9 into 1 plus 1 by 2. The value going to be equal to 5. Isn't it? Check once. So this will be minus 3 sin 3x plus sin x by 2x. Again the form is 0 by 0. Form 0 by 0 means we can differentiate once more. Minus 3 into 3 cos 3x cos x by 2. Now put x equal to 0. Minus 9 plus 1 by 2, that is minus 4. So value going to be minus 4. So option C is correct. Clear? This is an ideal application of L'Hopital rule. Hope you will try the same problem with the help of using the infinite series for sin x, sin 3x and cos 3x. You try once. JEE Mains 2025, it came that modulo x, GIF, greatest integer function, M and respectively with the numbers of the points or the function. See the function modulo x plus mod x minus 2 for this thing, not continuous and not differentiable. Then m plus n is equal to what? This is not like evaluation of limit, it is a direct question from the concept of limit on, better, continuity on modulo and modulus function. It is not continuous and not differentiable. We should remember that concept you have just got. Function differentiable means it is continuous. But the converse is not true. Continuity never implies the differentiability of the, sometimes it does, but not always. It is not confirmed that function continuous means it will be differentiable. There is no problem with continuity of modulus function. This function mod x minus 2 continuous everywhere. Am I right? This is continuous everywhere. But modulo x is not continuous at the integral points. Okay? Another thing, that mod x minus 2 is not differentiable at x equal to 2. Modulus function, there will be a sharp corner at the point x equal to 2. So, if we list all these informations here for modulo x is not continuous at integral points. What are the integral points in this interval? The interval they have given, x greater than minus 2 and less than 3. What are the integers lying over there? Is not continuous at x equal to minus 1, the integer lies over there, 0, 1, 2. Okay? And mod x minus 2 is not differentiable at x equal to 2. So this point x equal to 2, it is neither continuous nor differentiable. Now, if the function is not continuous at those integral points, how it can be differentiable over there? So the function will not be continuous at these 4 points. The function will not be differentiable at those 4 points. As the point x equal to 2 will not count for x equal to 2 separately. Now look at the question. They have given m stands for numbers of points where the function is not continuous, and n stands for not differentiable. We have just got the 4 points. So m going to be 4, n is also 4. Then m plus n going to be equal to 8. Okay? So I think this was the easiest in this year. Those who are good at thinking continuity and differentiability just on simple functions, I'll tell you this is a board level questions. Believe me, CBSE board, if it arises, you cannot say that it is out of syllabus. Okay? So I'll tell you again and again, it's a board level question, can be asked for your board exams even. 2024 1st February, evening shift. So this function f(x) equal to 2x square plus 5x, 5 mod x, mod function is there, mod of 2x square plus 5 mod x minus 3. X belongs to R, Mn denote the number of points where f is not continuous, not differentiable. Similar to previous one, m denote number of points where it is not continuous, n number of points where not differentiable. Now, you have to find the values of m and n. Whenever mod of something arises, my suggestion is that you go for graphical method. Graphical method will not take much time. I am taking time to explain it to you. But you can draw the graph of the function easily. Is it? Not very easy. Just look at the function given here. f(x) is mod of 2x square 5 mod x minus 3x belongs to R. Let us first draw the graph of the function. This function we can rewrite as mod of, see, x square and mod x square, they are same thing. You should agree. X square mod x square, same thing. It will be 2 mod x square 5 mod x minus 3. So here this sum, if somebody has taken, let gx equal to 2x square plus 5x minus 3, graphically it will represent a parabola. Then g of mod x, in the previous session I have discussed, g of mod x is what? How to get the graph of g of mod x? Try to remember. This graph we can get. We will remove the portion of the graph on the left side of y-axis, then take mirror image, all these things. But graphing is not completed here. We have to draw mod of g of mod x also. Then we will get 2 mod x square 5 mod x minus 3. Isn't it? Now, how to get the graph of these functions? This is our fx, no? Fx is mod of g of mod x. Question is how to plot the graph of all these things one by one, step by step. First we will draw 2x square 5x minus 3. 2x square, this can be factorized. 2x square, this is nothing but 2x minus 1 x plus 3, x plus 3, 2x minus 1. So zeros of this quadratic function, which is going to represent a parabola, is minus 3 and 1 by 2, and x square coefficient is positive. So the graph going to open upward. Okay, so zeros are what? X minus 3 and 1 by 2. Let us plot the graph of the function now. Minus 3 and say there is half over there. So the graph of the function, it is not symmetric. There is another problem. But we can get the point of intersection with the x-axis. No, x-axis we got, that is 3.5 with y-axis. See, for x equal to 0, g0 is going to be minus 3. So you get some idea about the graph now. This is minus 1, minus 2, minus 3. The graph might have vertex somewhere like this. From here, or vertex we can get also, but that part I am not going to cover now. This part parabolic, and this parabola, whole of parabola is almost like this. This is 0 minus 3. Without much effort, the rough sketch we got. No one will see your graph. They will see your calculation only. Okay. Now, next part, we have to get the graph of g of mod x. This is the graph of gx. That is gx equal to 2x square 5x minus 3. Now we are going for g of mod x. What do you have to do? 2 mod x square 5 mod x minus 3. You have to remove the portion of the graph lying on the left side of origin. Okay. Left side of x-axis. and then take reflection of the remaining portion about the y-axis, isn't it? This is the concept. So apart from this part, if you remove the part here, this portion fully will be removed. It will not be over there. So remaining portion graph we have to draw first, and then you take the mirror image. This is the graph of what? By removing the left hand side part. Then take mirror image about the y-axis. So the graph going to be like this. Okay? Because this is symmetric about y-axis. So at this point the graph will move sharp upward, here also upward. So there is a chance, no chance, there is a sharp end at 0 minus 3, isn't it? Let us complete the graph of mod of gx now. How to get mod of gx graph? You have to take reflection about the x-axis of this one. This part is what? 1 by 2, 0. This has to be minus 1 by 2, 0. So when you plot the graph by taking reflection of the lower part, this time we are going to erase this part. But we will erase after taking the mirror image. So the final graph will be almost like this. We have to take reflection of this part. Okay, this is short. So this 1 by 2, 0 minus 1 by 2, 0, and at the point 0 there will be different tangents. At this point even if you draw tangent, unique tangent is not there. So the function is not differentiable here. Not differentiable. Not differentiable at half. Not differentiable at minus half. Okay, but continuous everywhere. There is no point of discontinuity. And in the question, it was given M is the point where it is not continuous. Okay, so this function graph shows that M is equal to 0 over there, and in non-differentiable at how many point? Non-differentiable at x equal to half, 0 minus half, n is 3. So m plus n going to be 0 plus 3, this is equal to 3. Understood?